Hi there, in this video I'm going to do a revision question on differential equations. So let's take a look at the question. Question number 3. Solve the following first order linear differential equations, and in part A, dy over dx minus y is equal to x. So let's think about how we're going to solve this equation. Let's go back to the paper and pen. Now, the question did say it's a first order linear differential equation. And if you want to check whether that is the case, remember, if you have any equation of this type, dy over dx plus px into y is equal to q of x, and px is a function involving x only, and qx is a function involving x only. So px and qx are functions of x. And if you have an equation of this type, you have a first order linear differential equation. Now, if you're unaware of the method, let's go to the screenshot explaining the method. So for step number 1, we need to write our given equation in standard form. That is, we need to make the coefficient of dy over dx equal to 1. Now back to the paper and pen. Looking at this equation in question, this equation is already in standard form, and the reason is because the coefficient of dy over dx is already 1. So in step number 1, let me leave the equation as it is. Dy over dx minus y is equal to x, and the coefficient, as you could observe, is already 1. So in this case it's in standard form. So coefficient of dy over dx is equal to 1, which implies standard form. Now what I tend to do is I name the standard form equation, so I'm going to name that star. So star is my standard form equation. Now let's have a look at what step number 2 is. So back to the screenshot. Now step number 2. Step number 2 is we need to calculate the integrating factor, and that is abbreviated by IF. And to calculate IF, the integrating factor, the formula is e to the power of the integral of px with respect to x. And I made a note that if the power when integrated contains ln, then go one extra step, use the result e to the ln a is equal to a to simplify IF further. So bearing all of that in mind, back to the paper and pen. So over here, px is the term in front of y. So px is the coefficient of y. The coefficient of y is minus 1. So I'm going to make a note that px is minus 1. And remember the formula for the integrating factor IF, it's e to the power integration of px with respect to x. Now since px, the coefficient of y, we noted as minus 1, then IF will be e to the power, the integration of px, which is minus 1, with respect to x. And if we integrate minus 1, it's minus x. So that is what you should have for the integrating factor IF. IF is e to the minus x. So back to the screenshot. Now step number 3. Multiply the equation in standard form, which is star, by IF. So we need to multiply every term in our equation by IF. Back to the paper and pen. So here is our standard form equation star. Let's multiply every single term in that equation by e to the minus x, which is IF. So let's make a note. So multiply star by IF. So e to the minus x times dy over dx, that is e to the minus x dy over dx. E to the minus x times minus y, that is minus e to the minus x y, and that is equal to x times e to the minus x is x e to the minus x. So remember, multiply every single term in your equation star, by if, which is e to the minus x. Now, back to the screenshot. In step number 4, by the product rule, and this is always the case, by the product rule, the left-hand side of the equation can always be rewritten as d by dx of ify. So, back to the paper and pen. So, here is step number 4. So, this entire left-hand term of your equation can be rewritten as d by dx of if times y. So it's always d by dx of ify. So if, bearing in mind, is e to the minus x. So let's use this. So we have d by dx. If is e to the minus x into y. And that is equal to the right-hand term, which is x e to the minus x. Now, this is no trick. This is always the case, as I say, because if you differentiate this, you're going to end up with this term here. So it's always the case that when it comes to this step, when you differentiate this term, you're going to end up with this term in its entirety. So let's see what step number 5 is about. So back to the screenshot. So in step number 5, last step, integrate both sides. That means that we need to integrate the left-hand side as well as the right-hand side. Back to the paper and pen. So in step number 5, so by integrating both sides. So if we integrate something that we differentiate, we're going to be ending up with this term here. So we have e to the minus x times y. And however, we need to integrate the right-hand term also. So we need to integrate x e to the minus x with respect to x. So just as a recap, whenever you integrate something that you differentiate, you always end up with the term here. So which is e to the minus x into y. However, you need to integrate that right-hand term. Now let's think about this integral. To integrate this term, which I'm going to call 1, we need to integrate that by parts. So let's integrate number 1 by parts. So on the reverse, as a side calculation, we're going to integrate number 1, which is x e to the minus x, with respect to x. So remember the by parts formula. So here is the by parts formula as a reminder. The integral of u dv over dx with respect to x, that is uv minus the integral of v du over dx with respect to x. Now choose your u and dv over dx so that v du over dx is easy to integrate. So I'm going to take my u to be x. That means that dv over dx is the remaining term, so dv over dx is e to the minus x. So let's calculate du over dx as well as v in order for us to use the by parts formula. So du over dx, when I differentiate x here, it's 1. V, I need to integrate dv over dx, so we need to integrate e to the minus x with respect to x. That should give us minus e to the minus x. And now we have everything that's required for us to use the by parts formula. So let's use the by parts formula. Integration of u, which is x, dv over dx, e to the minus x. And the left-hand term corresponds to what we need to integrate. And that is equal to u is x, multiplied by v is minus e to the minus x, minus the integration of v, which is minus e to the minus x, multiplied by du over dx, that being 1. Now, before we integrate, especially this term on the right, let's get rid of the brackets to give us x times minus e to the minus x is minus x e to the minus x. Minus times this minus is a plus, so it's plus the integration of e to the minus x times 1 is e to the minus x with respect to x. And if we go one stage further, we're going to have minus x e to the minus x plus, and when we integrate e to the minus x, it's e to the minus x divided by minus 1. And let's just add c. So one more stage, we're going to have minus x e to the minus x plus, and a minus is a minus e to the minus x plus c. So this should be the solution to integral number 1. Integral number 1 is the solution to this integral on the right hand side. Let's put this all together. So for the left hand term we have e to the minus xy. So e to the minus xy, that is equal to, and for integral number 1, here is the solution. So let's copy that down. So we've got minus x e to the minus x minus e to the minus x plus c. So that should be the solution to question number 3, part A. So that ends this example. If you're unfamiliar with the concepts that I've used to solve this question, I will provide links to videos that I've created explaining the concepts in detail, along with additional examples in the description below. So be sure to check out these videos. Other than that, I hope you enjoyed this video. I hope you found this video helpful. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice exercises, and I hope to see you again. Thank you.